Okay, let's turn our cube into a six-sided die by drilling different patterns of dots into each of the six faces. This will introduce the topics of center drilling, and fusion parameters, all of which are really useful tools. Open up your previous cube file in Fusion and add a new sketch and place it on the top face of your cube. Change your line type from normal lines to construction lines. Construction lines are going to show up as dotted lines, and you can think of them as light pencil marks that help you place and orient real lines, real features. Then change to the line tool and draw a vertical line perfectly centered on your cube and a horizontal construction line perfectly centered on your cube. And you'll know they're perfectly centered because these little triangle icons will show up. Then change to the offset tool and click on this vertical line to offset a new line from it a certain amount. Let's offset it 0.22 inches, about a quarter of the way across our cube. And with that same offset tool, offset another vertical line the other direction, negative 0.22 inches. And again horizontally, 22 inches, and again horizontally, negative 0.22 inches. I'm starting to imagine those 6 dots on the side of the die representing the number 6, but I'm feeling like they're too squished into the center, and if you're like me, you might be starting to feel sad because repositioning each of these intersecting lines means changing the 0.22 inches 4 times. What if I change it and still don't like it and have to change it again and again? Isn't there a better way to arrive at a feeling that all my intersections are at the right spot? Well, that's where parameters come into play. And if you remember all the way back, that's why Fusion is a parametric modeling tool. It's a really powerful part of the tool set. So let's rebuild these parametrically. Go to the Modify menu and come down to Change Parameters. Hit the plus icon to make a new user parameter and give it the name Spacing. You can give these any name you choose, just make them clear what their intent is. In the expression field, you can get really complicated, or you can just put a number. Let's just put a number, 0.22, and click OK. Now I've got a user parameter called spacing, whose value results in 0.22 after calculating the expression. Let's use that instead of this hard-coded 0.22 that we typed in 4 times. Double-click on one of those 0.22s to edit it and type spacing, and notice how our user parameter spacing pops up. Hit Enter, and you'll see this little FX show up next to 2.2. That's your clue that we're now drawing the data out of the spacing parameter. Go ahead and add it the other 3 times, and when it was supposed to be negative 0.22, write negative spacing. And when you've got all 4, go back to the Modify menu and choose Change Parameters again, and this time change your parameter. Change it to 0.25, and notice how all of your spacings change to become further apart. Change it to 0.3, and notice how they change to become even further apart. This is the power of parametric modeling, one parameter to control many changes in your model. Click OK, and now let's do something with those intersecting construction lines. Go up to your Create menu and choose Point, and place a point near this intersection, but not on it. Just make sure that it's clear that you're not on it to begin with. Then come to your Constraints panel and choose the Coincident constraint. Let's make this point coincident to this horizontal line. So click to activate the Coincident constraint tool, then click on the point, then click on the horizontal line. This makes the point coincident with the horizontal line, but we don't have to stop there. We can make it coincident to other things as well, like this vertical line. Click on the point again, and then click on the vertical line, and now that point is coincident to both. And the only point coincident to those 2 lines is the point of intersection. Now, wherever those lines go, whenever we change our spacing user parameter, that point is going to come along for the ride. This is powerful. Good. Go back to the Create Point tool and add the other points needed for the number 6, and go ahead and add the point in the center while we're at it. And then use your Coincident constraint tool to make each point coincident with the 2 lines needed to snap that point to the intersection of those 2 lines. And now let's create a bunch of circles whose center is that point and whose diameter is 1/8 of an inch, 0.125. And as soon as I say a bunch of circles, that should get you thinking about those user parameters again. So go ahead and modify, change parameters, add a new user parameter called dot_diameter, whose expression evaluates to 0.125. And then double-click on your hard-coded 0.125 and change it to dot diameter so that it is expression-driven, parametric. Now, one quirk of Fusion, I tried to create the other circles and just type in dot diameter immediately, but it didn't stick. It gave me 0.125, but I didn't get the little FX in front of it, and I didn't notice until I had made all of these. So I had to go back and double-click on those 0.125s and type dot diameter. I don't know why it doesn't work the first time. I hope the Fusion developers notice and fix this quirk. Now, if I bring up my user parameters window, I've got essentially a control panel here where I can make my dots bigger or smaller in diameter and the spacing between the dots bigger or smaller until I arrive at a look and feel that I'm satisfied with. The one thing that I'm not going to change this time around is the diameter right now, because the tool that I want to use to make these dots is a 1/8 drill. That's not going to change. But I do want you to see that it's possible to change these diameters along with the spacings on the fly. And I also want you to see how cool it is that you can bring a whole shape along for the ride as those intersections change position. Next up, we're going to talk about how to build the cam for all 6 sides of the die without bothering to move this sketch onto all 6 sides in 3D.